For me. Yes, sir. They both are x. You compose f of g and g of f, and they are both x. That happened once yesterday, and I said that's a special scenario, which we're going to talk about today. What? Yes, yes, I can. I didn't hear you the first time. F of g of x. So we're plugging g in for f. So 4, plugging this in here. 4 cancels with the 4, leaving us with x. G of f, which I'll write in a different way this time, so you get used to seeing it both ways. G of f of x was x over 4x. Wait, what am I talking about? Yeah, I don't know what I was thinking. Which was 4x over 4, cancel, cancel, also leaving you with x. When that happens, that means you have found two functions that are inverses of each other, which is kind of the entire basis for today's lesson. Inverse functions are perfect opposite functions to one another that basically, when you put them together, they filter everything out and just leave you with x. They are perfectly opposite functions. Yes, sir. These, yeah, times 4 divided by 4, nice counter, right? Some of them are going to be a little harder to recognize, but you will notice patterns that'll help you do it quicker, so I like that you're already thinking that way. So, put away your DOM, open up some notes for 1.8, and we're going to start finding inverses. Sí, uno ocho. What's the point in between? Here we go. All right. The first few. Now, number 1 is straight from the DOM, but basically, the exercise is 1 through 10. Take both compositions and determine whether each pair of functions are inverses of each other. If they both go to x, then they are. So this one would have been a yes, or as I like to put, a smiley face. If they aren't, then it is a frowny face. It is a no. Now, because of my horrible lack of participation yesterday, with the exception of 2 or 3 of you, I'm going to be calling people at random to answer my questions today. But first, let's do one more together. How about number 5? Let's look at number 5. Let's try that one. First, f of g. That's f of g. I'm going to leave off the x just to save space. Times x plus 5 over 9 minus 9. Does anything cancel here? The 5 doesn't cancel. I mean, you could distribute the 5, but in the end, nothing's really going to go away here. So this one, I'm just going to stop right here. As soon as you see one's not going to go x, then they are not going to be inverses of each other. You could just stop. Those are not inverses because it does not filter down to x. Let's look at 7. Start with f of g. 3 over. Now we have to plug this whole function in for x. 3 over x plus 4 minus 4. I just plug this in for this x. Plus 4 minus 4, leaving us with 3 over x, which is the same as what? Nick, what's that the same as? Not quite. What do we do at the bottom? When you divide by fractions, you really just do what? There you go. Flip and multiply. Yes, it does. Yes, it does. Now we're going to do g of f. Same difference. 3 over quantity. 3 over x minus 4 plus 4. What's going to be my first step here? Gabrielle, what is, yeah, there you are. I was looking back there. What's our first step here? They will, but first, this 4 is wrapped up in a fraction, so we can't take it out yet. So what can we do with this fraction first? Same thing we did with this one. There you go. Let's flip and multiply. Now the 3's will cancel, and the 4's will cancel, and that will leave you with x. So are these two inverses? Yes, they are. It's chinless smiley. Any questions about what we're looking for in these? Yes, sir.
Are we gonna do some way where it's like that would be like X would be like
Not for inverses. I mean, you might be doing stuff like that later, but the question will not ask you, are they inverses with the number, because you don't need numbers to know that. Yes, ma'am? No, go ahead. What were you saying?
can you determine the inversions if you use the number?
I'll be showing you that a little later. Oh, you're thinking ahead. Love it. Yes, ma'am. Say it one more time. There are ways you can be able to look at it and tell whether they're going to be or not, but here's the reason that those don't, like for instance, you might notice times x divided by, or excuse me, times 4 divided by 4, like you mentioned earlier. But like here, sometimes those can be a tad misleading. You see 3 over x, and 3 over x, you're thinking, whoa, that's kind of the same thing, so those won't be inverses because it's not opposite, but in fact they are. So there are ways you can look to have a good idea whether it's going to be or not, like this one. Times 5, and then we didn't divide by 5, we added 5, and those definitely aren't opposite of each other. So you could have assumed it was no. I mean, I still want you to work it out. But I would advise working it out to play it safe. Did that answer your question? Okay. Now, what's different about number 9? Let me take number 9 elsewhere so we have more room for him. Number 9 is interesting. Why? They're both negative, but they're both the exact same thing. Well, let's look. If we actually work this one, stop it. F of g negative negative x, what's that? X, and if you did g of f, it's going to be the same thing. Two things can be their own inverses. There are a few functions that are their own inverses. 22. What? I may have just mentioned the homework number today where that's going to happen, because I had people going, whoa, this doesn't make sense. Yes, numbers can be their own inverses of each other. So watch out for that. All right, let's move on. All right, for exercises 11 through 28, all are one-to-one functions. By the way, all that means is, I don't know if you remember back when we were first talking about functions, we did the whole bread, toast, bagel, toasted bagel, baby seal, toasted baby seal. That's all it means when it says one-to-one. It means we're giving you things that we already know are functions. You don't have to worry about them not being functions. So that's just, you don't need that. Part A, find an equation for the inverse. So you have to find your own inverse. They're not going to give you two. The procedures for finding your own inverse are rewrite the equation with a y instead of an f of x. Step 1 for every one of these. You're finding the inverse of a function. Rewrite the original with a y instead of an f of x. Yes, ma'am. Sure. In fact, not only will I write it in words, I'll write it in legible words. You're welcome. Step 1. Let's see. What did I just say? Oh, I didn't even write anything. Can't do that. Okay. Oh, it's because I put a colon. They don't know how to do punctuation. All right, step 1. Rewrite the function with a y. Convert that, dang it. Oh, I switched it. Never mind. Step 2. What is happening? Oh, I hit the wrong icon. Here we go. Step 2. Switch your y and x. And I'll show an example of this in a second. Yep. Switch your y and x. And step 3, solve for y. It's a 3-step process. And I'll show you one in a sec. We got that? Alright, so here we go. So, first thing we do, step 1, rewrite your function with a y instead of an f of x. Step 2, switch your x and y value where they are in your function. Switch them. And step 3 was what? Solve for y. So, subtract the 3. Once you're done, that is your inverse of your original function. Once you've solved for y, that is your inverse. Now, part B says, verify that your equation is correct by showing exactly what you showed in the last slide. It says, well, in the last few problems, you just did where you composed them back and forth, and that told you whether they're inverses or not. So they're saying check them again. I'm not going to require you to do that for 11 through 28, so please remember that so I don't have to answer that question 100 times later. For 11 through 28, you do not have to do part B, but it is a helpful thing to know because on your test, there's going to be at least one question that says, here's a function, find its inverse. Well, if you have a master way of checking to see if you're right, that's a good thing to know. So, it's just remember that if you think something's inverse of a function, if you compose them back and forth, you should get x. So that's just a fail-safe way to check your answer. But I'm not going to require you to do that right now since you just got doing it with the previous problem. All right, let's see. How about number 17? Let's look at 17. So, step 1 is what? Switch it to a y. Very good. I forgot to call in specific people. I'm so bad at this. Step 2. What do I do now, Kyler? There you go. Switch the x and y. What's my third step, Maggie? Solve for y. Well, what is my first step to solving for y? I'll just stick it with you right now. You have to subtract first. You can't cube root until the cube is isolated. Now you cube root both sides, and that is your inverse. The opposite of cube is a cube root. And a fourth is a fourth root. And a fifth is a fifth root, etc., etc., etc. And then if you want, you can check it by doing what you did in the last few problems, but I'm not going to require that. Questions about this one? Okay. Oops, just kidding. Go back. All right. Yeah. Wait, what did you say? Let's just do the last 3 there. They all look kind of tricky. So I'm going to just take them all. First off, 23. Since I know you've written down the steps, I'm just going to work it real quick. So this will be x. I'm going to skip the first step. Equals the square root of y. Get rid of the square root by squaring. So that is your inverse. X squared. The second one is a tad harder. So, Rachel, what do you think my first step's going to be here for solving this green one? I've already rewritten it with x and y and switched them. Add the 3. Perfect. Now this next step is a little tricky. Everybody always wants to divide by 7. jump straight to y. The problem is, if you divide by 7, you're not setting it equal to y. You're setting it equal to 1 over y. So what you actually have to do is multiply by the y. Multiply the y over. So it becomes y times x plus 3 equals 7. Now, where a lot of people go wrong here is they start thinking, oh, I need to distribute. Oh, no, but now how do I solve for y? Don't bother distributing. Just divide by the entire quantity x plus 3. And you're finished. That is your inverse. Unfortunately, I think with the way the numbering is going to work out, you're not going to have to do one like 27, but I'm not going to promise you there won't be one on your test, so we're going to go ahead and work through it anyway. So, switch your variable, and you have 2y plus 1 over y minus 3. Now, the panic button might already be going off in some of your minds because you're saying multiple y's, so how do we just solve for one of them? Well, our goal, it's like 2y and 1y. If you can put them together as 3y and then divide by 3, boom, you've got it down to one of them. So our goal is to, at some point, mesh those two things together with distribution. So, our first step is to multiply the y minus 3 over to the other side. Now, unlike the last problem, you do want to distribute here. So that's going to be xy minus 3y equals 2y, oh, I'm sorry, 3x, yes, I apologize, plus 1. Now we want to put the y's on one side and the non-y's on the other side. Yes, ma'am. So, you get where this came from? Okay, so we just multiplied this over. That's where this came from. Then I just distributed and got this. Now we're going to move the y's to one side and everything else to the other side. So that becomes xy minus 2y when I subtract it over. And I'm going to add 3x over, leaving me here. Here's the moment of truth. Can I factor a y out of the left? Yes, I can. Now, just like the last problem, all I have to do is divide that over, and we're done. That is our inverse. Now, if you get one like that on the test, and you don't trust your answer, remember, compose. Put one into the other. See how it dissolves. Hopefully it'll go away. Although that's going to be really ugly, because there'd be like a lot of stuff going on. Anywho, questions? Okay. Moving on. Okay. No problem. This is probably the hardest part of the lesson right here, in my opinion. So if you can get this, you should be good to go. Okay. Already did that. Okay. Now, we're actually going to come back to this slide. I think this slide is easier if you first understand this slide. These are two random functions. And what they want us to do is graph the inverse given the original. Let me ask you this. When we composed our inverses and our originals, what was left? X. You were left with x. Just your function equals x. Or y equals x. You don't have to, that is the line for which a function and its inverse are symmetrical. The line y equals x, which I will do in this dotted green line to represent it better. The line y equals x is the line around where our function and our inverse function will be symmetrical. I'll go ahead and draw that in for both of these. So when you're done, your inverse should go right around that. Now there's an easy way to do this. First, list some coordinates from your original. Let's see, so that'd be 0, -4. Looks like 2, 0. I'm taking these straight off the graph here. 3, 2, and looks like 4, 4. To find your inverse, you just flip those coordinates. That's the handy thing about things being symmetrical around this line. You can just switch them. -4, 0, 0, 2, 2, 3, and 4, 4. Plot those, and that should be your inverse. -4, 0, 0, 2, 2, 3. Oh, I think I got off. Oh, 0, 2 is here. 2, 3, and 4, 4. Connect your dots. And if you were a better artist, this would look better than mine. But you can see how if you turn your head, those are supposedly symmetrical. Before we go on to the second one, did any particular step of the process there need a little bit more explaining? It'll always be that line for inverses. Always. So, the next one, it only gives us 3 coordinates. So we're going to find those. 0, 1, 1, 2, 2, 4. Flip them, plot them, and we're done. So, 1, 0, 2, 1, 4, 2. You can kind of see the general shape of the other one, so that'll kind of help us draw it. Questions on that? Okay, now let's think about something for a second. What if I had given you this function? You know what? Nope, it's not going to be any way for me to do that. I'm just going to draw one over here. What if I had given you this function here? Here's an axis. And I said, here's your original. Draw your inverse. Well, you're going to take these points. You're going to plot them. And you'd connect them. That second one, now I just sketched that, but if you were to take the point, that would be approximately the inverse to this, if you were to do that same point switching. Look at our inverse here. Is that a function? What do we have to do to a graph to determine whether something is a function? Vertical line test. Does this pass the vertical line test? No, it doesn't. It's twice there, 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 there. That's why the square root function that we deal with, we only deal with the top half. But the full function here, no, it is not. Now, there's a way to be able to look at the original and tell whether your inverse will be a function or not. And that is, if you can look at your original and it passed the horizontal line test, which this one doesn't, but if it does, then you'll know that your inverse would be a function. And if it doesn't, it's not. So let's go back to the other one. This slide. Let's look at the first one. Does this pass the horizontal line test? No, it touches twice here, 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 here. So its inverse will not be a function. And that's all you need to write for snap case. What about this one? Nope. It's here, 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 all those places. No again. What about this one? Yeah, that one touches just fine. Its inverse will be a function. Smiley face. So that's the whole principle there. Horizontal line test will tell you if its inverse will be. Only time I see people get confused with this is they actually draw the inverse and then do the horizontal on that. Well, if you're going to draw the inverse, then you might as well just do the vertical because you've already got it. But so that you don't have to draw it, you can just use the horizontal with the original. The original.
How is the third one touch the horizontal?
Because it doesn't touch more than once anywhere. I mean, it flatlines eventually, but it's ever put slightly going to go.
Is that through inverse that doesn't have the vertical, so it won't be a function?
Well, what I was saying was,
Oh, it's the regular.
yeah, the whole point of this was to be able to say, well, if we found our inverse, would it be a function? Well, if you've already found it and graphed it, you might as well just do it the old-fashioned way. But without having to do that, you can just do horizontal with the original. So it's just a save of time. Questions on that? All right. Let's see. All right. This is just putting together everything we've done so far. Only thing different is at the end they want you to look at the domain and range. I want to hear a prediction. Think about this. If our x's and y values just switch when we graph them, who has a prediction about our domain and range? Those are just going to switch too. And we'll look at one to show you, but everything else is what we've already done. We're going to find an inverse by switching the letters and solving. We're going to graph them like we just did on the last slide by finding some coordinates. And then we're just going to state our domain and ranges. So I'm going to jump straight into one of the harder ones. Let's look at number, I didn't number these. Let's look at the third one. I don't guess I need to take it anywhere, so that's not what I'm doing. Let's do the third one. What am I doing? I have to find the inverse first. Here we go. Part A. Switch the letters. And find the inverse. What is step 1 here, Austin? Yes, I've actually already done that. So, you're right. You're right. What's the next step here? That's a better way to word it. Isn't that what you just said? There you go. There you go. Solve for y. All right. So, what do I do to solve for y here? Yeah. Well, that's what I meant to ask you the first time. I just missaid it. Yes, you would, because it's of an entire quantity. And then what's my last step? There you go. Notice, because we're adding the one after we square rooted, it will not go into the radical. That's really the only difference between like this one and this one, is the order of which you have to do everything depends on whether your number is inside or outside the radical. Okay, so here's our function. Here's our inverse. Now we need to graph. Now it gives us a specific domain for which to graph these. X is less than or equal to 1. So I'm going to make an XY chart and plug in values less than or equal to 1. And you're going to plug those into your original. Your original is the one that domain applies to. So Rachel, what y values am I going to get when I plug in these x values into this function? When I plug in 1, what am I going to get? 0. When I plug in 0, -1. Very good. And -2. Very good. So here I go. I'm ready to graph. Finally. I'm going to go ahead and graph that before I worry about my inverse. Alright, so 1, 0. 1, oops, what am I? Yeah, 0, 1. -1, 4. And -2, 9. And we're way up there. Arrow. Now, just from a second ago, don't reinvent the wheel here. What's the easiest way to graph my inverse? Justice. Switch the coordinates. So that becomes 1, 0, which it already was. 0, 1 is going to stay the same too. 4, -1. And 9, -2. Connect the dots. Now you can draw in your little imaginary symmetry line if you want to better see it. Does that look pretty symmetrical? I think so. I think it looks pretty good. Last thing, only thing left, we have to state the domain and range for each. What was the domain of the original function? It kind of told us. Yeah, less than or equal to 1. Or, in other words, -infinity to 1. Like that, right? That was the domain of the original. What was the range of the original if we just look at our graph here? How low does it go? What is the lowest value that this function went to? 0. And how high did it go? You're right, we stopped at 9, but we could have kept going and it would go all the way up to infinity. Right. Now when we look at our inverse domain and range, let's look at that. How far left did our domain go? I didn't draw the coordinates, but if we look at it, what's our leftmost coordinate here? What's the x value? 0. Now how far right's it going to go? Infinity. You see the pattern? That's what the range was over here. What do you think the range is going to be on this side? Negative infinity to 1. Oops. Sure enough, range, negative infinity, all the way up until 1. Your domain and range will switch because your coordinates switch. That's the whole point of those problems, is to get you to notice that. And because it'll be every other region, you're only going to have to do 1 or 2 of them. So, that's good. Yes. Right here? We plugged in negative 1 into our original. Negative 1 minus 1 is negative 2. Negative 2 squared is positive 4. Yes. In fact, if you punch that into a calculator, if you punch negative 2 squared into your calculator without using parentheses, it's going to tell you negative 4. Because it does an order of operation, it's going to square and then do your negative. So you might have to use some common sense with some of these and just remember, whenever you square something, it's going to be positive. So bear that in mind. Other questions from this slide? They're all going to be just about that same exact thing. Solve the function, graph them both, domain and range. Okay. Moving on. I kind of was frustrated about the fact that they added these in. Basically, all you have to do here is find the inverses. They just want you to get used to the fact of knowing that to get rid of a root, you just raise it to a power. Like square root, you square it to get rid of it. Cube root, you cube it to get rid of it, etc. That's the whole purpose of the slide. I think it's a little out of order. I wish they'd put it earlier. But like, just real quick, to find the inverses, so that'd be x equals square root of y minus 1. How do we get rid of the root? Square both sides. Add the 1. And there's your inverse. Second one, let's see, that'd be x equals the cube root of y plus 1. Corey, what do I need to do? You're right, but what do I have to do before I do that? Yeah. That's different than this one because here the square root went with everything. Here it didn't. So, now what do I do? Now you cube it. And make sure you have to cube everything, not just the x. You have to cube everything on that side. And you don't have to bother expanding that. All we were looking to do was solve for y. Isn't that right, Pierce? Yeah, that is right. And you're done. Questions on those? Let's just find the inverse. So I don't even know why they really needed to add this, because we've already done this earlier in the lesson. Okay. These last two are my favorite two slides of the thing because they don't require much actual math. It's just kind of a word search. Or we're going to kind of work inside out. First thing, what is g of 1? So you go to your g function, find where x is 1, and what's my y value? 1. So now I'm going to find f of 1. So f, go where it's 1, what's my y value? So this whole thing is 5. Try the next one. Go to f, where x is negative 1, what is my y? Positive 1. So then I go to my g and find where it's positive 1, what's my y? Positive 1. Now this one looks a little different. We'll talk about it in a second. The first part starts the same. Where x is 10, what's my g? Negative 1. Now, who thinks they can tell me what the inverse is going to do? Why is that going to change this? How is it going to change this? There? That's right. Instead of looking for an x value of negative 1, because it's an inverse, we're going to look for a y value of negative 1. And what's that going to make my x? 2. So the whole thing equals 2. Right. Anytime you have an inverse, you just look for the y instead of the x, because it flips your coordinates. Very good. Questions about that? Nope. This slide is the exact same thing, except they didn't give you coordinates, they just gave you functions to plug them into. So like this one, you plug 0 in for g. So plugging 0 in for g, that's 0 minus 1, negative 1. Now I need to find f of negative 1. So I come up to f, plug it in, and what's that going to be? Negative 7 when you plug it in. Just like before, instead of plugging in 1 for my x value here, because it's an inverse, what do you think I'm going to do with it? Plug it in for my y, which essentially means solve for that. So I go to my f. Remember, this is the same as y equals 2x minus 5. Plug the 1 in for the y and solve. Add 5, divide by 2, and you get 3. And this third one's just showing off. Plug in 1 for the h, then plug that in for the f, then plug that in for the g. This is really the hardest one right here. Just remembering to plug it in for the y and not the x. Well, you guys have been a very patient class. It's been a very lengthy lesson. There you go.